Okay, so today we're going to be going over solving multi-step equations. You would have seen these before. A multi-step equation is just an equation that takes more than 2 steps to solve. Oftentimes now in Algebra 2, we'll see this phrase solution set. And it's a list of all possible solutions for an equation. And it's usually written in squiggly brackets. It'd be written something like this: x equals squiggly bracket a1, or the first solution, comma, the second solution, and so on. So this is my general rule for solving multi-step equations right here. The first thing I do is I simplify both sides of the equation. The second thing I do is I collect the terms with the variables to one side of the equation. And then I solve with reverse order of operations. Typically, if you follow these steps, you usually don't make mistakes. Well, at least with the this part right here, the second step. Usually, people do make a mistake if they don't move the variables before they start moving at other things. So I recommend moving the variables first. It does save a common mistake. Okay, so example 1. Going down through, the first step I had listed up there is to simplify both sides. So that's what I'm going to start off by doing for example 1. I am going to distribute this through, give me 15 equals negative 3x plus 3. The plus 9 comes down. Next thing I'll do is combine like terms. I'm going to continue to simplify both sides until I can't do anything else. Everything else comes down. Notice now that I can't simplify either side, I would try to move all the variables to one side. That's already the case. So now I'll just solve with reverse order of operations. I'll subtract 12 from both sides and get 3 is equal to negative 3x. Then lastly, to finish getting x by itself, I will divide by negative 3. Going through reverse order of operations, leaving me with x is equal to negative 1. Example 2, we're asked to find the value of x. This problem, notice it's two intersecting lines here, and these two expressions are referring to the angles. You may recall from previous years of math that if the angles are straight across from each other, then the way they are related is that they are equal to each other, or congruent. So that means we can start by setting this up. 6x plus 3 equals 8x minus 21. If I go through those same steps I did in the previous problem, the first thing I want to do is try to simplify either side. The left side I can't do anything to simplify, nor can I with the right side. So both sides are simplified. The next thing I will do is I will move the variable. So I'm going to move everything to my left. So I'm going to subtract 8x from both sides. That's going to give me negative 2x plus 3 will carry down. And equals will carry down. Minus 21 left on the right side. Now that my variables are all on the same side, I can just simply go through a reverse order of operations. So get rid of addition and subtraction. So I'll subtract 3. So negative 2x is equal to negative 24. Then lastly, divide by negative 2. So I get x is equal to positive 12. The next one is example 3. We have 5m minus 2 times, in parentheses, m plus 2. And that is all equal to negative 2m plus 15 in parentheses. Okay, if I go through this, again, those steps I said is to simplify both sides. So I'm going to start by distributing negative 2 on the left side here. That's going to give me 5m is equal, not equal, sorry. 5m minus 2m minus 4 as I distribute that through. On the other side, notice I have a negative sign in front. You may recall from previous years that if you have that there, it's like having a negative 1 now in front. So I will distribute a negative 1 through. So negative 2m minus 15. Next thing I'm going to do is continue to simplify. I can still do something on the left side here. I have like terms. So I'm going to combine like terms. 5m minus 2m is 3m. My minus 4 equals negative 2m minus 15 comes down. So now I've simplified both sides of the equation. The second step I had listed was to move the variables to one side. So I'm going to again choose to move it to the left side. So I'm going to add 2m to both sides. These will cancel. Give me 5m minus 4 comes down equals negative 15 on the right side. Now that I have the variables on the side, it's simply a two-step equation. So go through with reverse order of operations. Add 4. Get 5m equals negative 11. And then divide by 5. So we get that m is equal to negative 11 fifths as a fraction, or as a decimal, that is negative 2.2. Okay, lastly, we have what I have called special cases. Special cases occur when the variable cancels out. If what you have is, if what's left after the variable cancels out is true, then the answer is all real numbers. If what's left is false, then the answer is no solution. Okay, so example 4 will deal with a special case. If I go through and solve this using the same process as we had before, which means I'm going to simplify both sides of the equation. The left side you can't do anything with, but the right side I will distribute through. So I'm just going to bring the left side down. So if I distribute through, I get 10 minus 8a. I can't simplify either side anymore. So next thing I will do is I will move the variables to one side. So I'm going to add 8a, add 8a. Those are going to cancel. Oh look, they cancel on this side as well. My variable has canceled out completely. So I'm left with 10 is equal to 10, which is true. Therefore, we say that all real numbers is the solution. And this little r here is the symbol for real numbers. A solution of all real numbers means that no matter what real number you plug in for a, it will make this equation true. So you could plug in 2, you could plug in 40, negative 10, 0, pi. Any number you plug in that is real would solve this equation.